Why putting your Wi-Fi router in the corner is killing your internet speed. You pay for fast internet. You might even pay extra for gigabit speed. But every single night, you experience the same frustration. You sit on your couch, and the video stream buffers. You try to play a competitive game, but the latency spikes, causing you to lose. You walk into your bedroom, and your phone quietly disconnects from Wi-Fi and switches to expensive cellular data. So, you do what everyone does. You blame the internet service provider. You blame the cheap router provided by the cable company. You maybe even go out and buy a $300 gaming router with 8 antennas that looks like a spaceship. But nothing changes. The dead zones are still there. The lag remains. Why? Because mechanically, the problem is not the hardware. The problem is the geometry. You put the router in the worst possible place in your entire home. The corner of the room. From the moment you place that device on the floor behind the TV stand in the corner, you guaranteed that 50% of your signal would be destroyed before it traveled even 1 meter. You are not suffering from slow internet. You are suffering from physics. By the end of this video, you will understand the invisible tax you are paying on your internet speed. We are going to dive deep into the radio physics of signal absorption and the inverse square law. We will explain why MIMO technology, the feature that makes modern routers fast, completely breaks down when placed in a corner. And we will reveal the specific utility protocol for router placement that acts as an instant, free upgrade to your entire home network. Let's look at the engineering reality. To understand why the corner is a death sentence for Wi-Fi, we first need to understand how the signal actually moves. Most people visualize Wi-Fi like a light bulb. They think if they turn it on, the room fills with data, just like a lamp fills a room with light. But this analogy is dangerous because it is incomplete. Wi-Fi is radio waves. These waves do not flood a room. They travel. And the way they travel is dictated by the antenna design. Almost all consumer routers use antennas that radiate signal perpendicular to the antenna itself. If your antennas are vertical, the signal spreads out horizontally. The shape of this signal looks like a giant, invisible donut. The signal is extremely strong on the horizontal plane, the sides of the donut. It is extremely weak directly above and directly below the router. Now, apply this geometry to your living room corner. A corner is formed by two solid walls meeting at a 90-degree angle. When you place the center of your signal donut in that corner, consider what happens to the energy. Mathematically, 3/4 of your radiation pattern is facing the open room. But the remaining 1/4, a massive chunk of your energy, is slamming directly into the walls at point-blank range. Depending on the construction of your house, this energy is either absorbed or reflected, and both are disastrous for your speed. Let's talk about absorption first. When a radio wave hits a physical object, it transfers some of its energy into that object as heat. The wave keeps going, but it is weaker. Drywall is relatively forgiving. Passing through one layer might only cost you half your signal strength. But if your router is in the corner, it's not just hitting drywall. It is hitting the structural studs, the insulation, the electrical wiring inside the wall, and possibly the exterior cladding of your house. If your house is built with brick, concrete, or stone, the absorption is massive. A solid concrete wall acts like a barrier, blocking almost all radio energy. If you place your router against a concrete retaining wall in the basement corner, you are effectively shouting into a pillow. The signal dies right there. It never reaches the bedroom upstairs. But there is a second, more chaotic problem: reflection. Radio waves behave like light when they hit dense surfaces. They bounce. Metal is the ultimate reflector. And where do people typically put routers? In the media corner, right next to a massive television, above a gaming console, next to a soundbar, maybe even near a window with a metal frame or a mirror. All of these objects contain metal. When the Wi-Fi waves coming out of your router hit these metal surfaces, they bounce back. This creates a phenomenon called multipath interference. Imagine throwing a rock into a calm pond. Ripples spread out evenly. Now imagine throwing that rock into a tiny bathtub where the ripples bounce off the walls and crash into each other. The water becomes chaotic. This is exactly what happens to your radio signal in a corner. The reflected waves collide with the fresh waves coming from the antenna. Sometimes they combine to make a stronger signal, but often they arrive out of sync and cancel each other out. This creates invisible null zones or dead spots. You could be sitting just 10 feet away from the router, but if you are sitting in a null zone created by a reflection off your TV, your speed drops to 0. This interference also destroys a specific technology called MIMO. MIMO stands for multiple input, multiple output. Modern routers use multiple antennas to send different data streams simultaneously. It's like having a highway with 4 lanes instead of 1. To make this work, the router needs a clear, predictable path to your device. When you bury the router in a corner, the reflections create so much signal noise that the router cannot distinguish the clear paths. It is forced to drop down to a simpler, slower transmission mode to avoid errors. You paid for a 4-lane highway, but the geometry forced the router to close 3 lanes. Now we must discuss the frequency trap. Modern Wi-Fi relies heavily on the 5 GHz band for high speed. But physics dictates that higher frequency waves have shorter wavelengths. Shorter wavelengths are terrible at penetrating solid objects. 2.4 GHz, the old standard, is slow, but its long waves can punch through walls. 5 GHz is fast, but it is easily blocked. When you place a router in the corner, forcing the signal to travel through even one extra wall or piece of furniture to reach you, the 5 GHz signal often dies completely. Your phone sees this. It realizes the 5 GHz signal is too weak. So it automatically switches you to the slower 2.4 GHz band. Suddenly, your speed drops from 500 megabits per second down to 40 megabits per second. You didn't change your plan. You didn't change your router. But the physics of that one corner wall filtered out the high-speed band, leaving you with the slow lane. And finally, consider the inverse square law. This is a fundamental law of physics. It states that signal intensity drops dramatically with distance. If you double the distance from the router, you don't get half the signal. You get 1/4 of the signal. When you place a router in the corner of a house, you are maximizing the distance to the farthest room. If your house is 40 feet wide and the router is in the far left corner, the signal has to travel 40 feet to the far right bedroom. By the time it gets there, the physics of distance has decimated the power. But if you place the router in the center of the house, the maximum distance to any room is now only 20 feet. By cutting the maximum distance in half, you mathematically quadruple the signal strength at the edge of your home. This is not magic. It is geometry. Central placement is the single most effective amplifier you can buy, and it costs $0. So how do you execute this? You need to stop treating your router like an ugly box that needs to be hidden. You need to treat it like a light source. Here is your utility protocol. Action 1. The central hub strategy. Look at the floor plan of your home. Identify the geometric center. Usually, this is a hallway, a living room, or a landing at the top of the stairs. This is your target zone. Even moving the router from a corner to a spot just 10 feet closer to the center can improve signal strength significantly in the far rooms. If your cable modem is stuck in the corner, buy a longer Ethernet cable. A 50-foot Cat6 Ethernet cable costs $15. Run it along the baseboard and move the router to the center. That $15 cable will do more for your speed than a $300 mesh system. Action 2. The eye level rule. Get the router off the floor. The floor is the worst place for signal. It is blocked by couches, coffee tables, and legs. Also, the floor is often made of concrete or contains in-floor heating pipes which block signals. Place the router on a shelf, a console table, or mount it on the wall at about chest height. Remember this signal donut. You want that donut to float above the furniture, not crash into it. Action 3. Isolate the device. Do not stack your router on top of your modem. Do not put it inside a media cabinet with glass doors. And absolutely do not hide it behind the TV. The TV is a giant metal shield that blocks everything behind it. Give your router at least 6 inches of clear air on all sides. Let the antennas breathe. Your router is the heartbeat of your digital home. But by leaving it in the corner, you are strangling it. You are forcing it to fight against the laws of physics every single millisecond. The lag, the buffering, the dead zones, they are not technology problems. They are placement problems. Stop blaming the provider. Stop buying expensive extenders that you don't need. Unplug the router. Move it to the center. And watch the physics work for you, instead of against you. Move it.